This video is for studying about the fragmentation and reassembly. We left with the previous video. There we had studied about IPv4, and IPv4 there we explained all the fields except the second row. There were three different fields. Those three fields were used for the purpose of fragmentation and reassembly. So those three fields are going to be explained in this video. So this is a continuation of IPv4 IPv4 field explanation, or the previous video, video number 3. So here we are introducing a new term, MTU, maximum transfer size. This is the capacity of the frame. So the next layer is the link layer. There the data is, the PDU is in terms of frames, and the capacity of one frame is known as the MTU. So a single frame, a single datagram will be composed of multiple frames. So fragmentation means dividing the entire datagram into multiple fragments. So the fragments are combined at the destination together to form the original datagram. So reassembling and fragmentation, these two processes are happening at the host devices in order to reduce the overload of the routers. In this figure, we can see a single datagram is divided into three fragments, and let us explain this with an example in the next slide. Here we can see the three fragments are there for a single datagram, and each fragment is having a maximum capacity of 1500, and the header length is eliminated. So the header length is 1020 bytes, that is subtracted from 1500, we get 1480 bytes of data. And the field ID represents, ID equal to X means all the fragments with the same ID number equal to X belongs to the same datagram. And the next field is fragment flag. It is a flag variable that represents the following fragments are the continuation of the current fragment or not. So all the fragments of the same datagram will have a fragment flag value equal to 1, and the last frame will have a value 0, means no more flags are followed by this current frame. So the last fragment will get the flag value equal to 0. For all others, it will be 1. And the offset represents the starting value and the ending value of each of the frame. So the first fragment will always start with the offset value 0. Then 185 is the second fragment starting value, that represents 1480 divided by 8. That is number of bytes. 1480 is the header length subtracted from the MTU. So become 1480. That divided by 8 is the number of bytes, that is the starting offset of the second fragment, and again 185 is added from 185, then we get the third fragment, that is 370 onwards. The starting value of each frame is given in the offset field. These three are the fields used in the header of the IPv4 for the purpose of fragmentation and reassembly. So when it comes in the destination side, the ID, fragment flag, and offset will help us to combine the frames together to make the datagram. Thank you.